Hello everyone, this is Chris, and in this video I'm going to be showing you multi-threading within SSIS. Now, multi-threading as a technique is where you have multiple worker threads all performing part of the task to hopefully perform that task quicker. Now, in SSIS, the way that I'm doing that is with a parent package and a child package, with that child package running multiple times in parallel. And I'm going to show you a particular scenario where that's really helpful in SSIS. So let's take a look at that now. Okay, so the scenario that I've had before is I've been calling an external API, and that API has only wanted to give me 100 rows at a time, which is fine, but actually I wanted hundreds of thousands of rows out of that API. Now, because it was an external API, I didn't have control of it. I couldn't ask for more rows, it would just give me 100 at a time. So because I wanted hundreds of thousands, and if you imagine getting 100 rows at a time, you're making the call, get 100 rows, make the call, get 100 rows, I thought about multi-threading. So setting up something where I could potentially have 4 threads and get 400 rows at a time, or 8 threads and get 800 rows at a time. You can see I've got an example here where I have actually got, I'm calculating the number of records per thread in the middle here, and I've got 1, 2, 3, 4, 5, 6, 7, 8 threads around it. Now, I wouldn't usually lay out an SSIS package like this, but I don't know, it looked quite nice, so I thought, why not? I do like straight lines, and I like a bit of consistency, so that worked for me. But what we're doing here is we're actually calling the same child package multiple times. So I'll just step you through some of it. What I'm doing is I'm calling away to an API that I've mocked up myself in Mockaroo, and I'll show you that in a minute. It kind of does the job of the API that I was calling to previously. Just as an example. So what we'll do first is we will just have a look at, so first off I'm just calculating how many records per thread. I've got a package variable for the total number of records and the total number of threads, and that's giving me my records per thread. If we just have a look at the package parameters here, I've got my base API call to Mockaroo. I've then got so the limit on the actual one that I was calling was 100. Here I've set a limit of 10, and I've just told it that the total number of records will be 1,000. Now, the example where I used it in the real world example, I could actually go away and call to it and say how many records are there for this particular scenario. For this one, because I've mocked it up myself, I haven't got a mock up there to give me a total, so I'm just specifying that myself. And possibly the best bit about this here is specifying the total number of threads. So whilst I have 8 threads in that package, I can actually choose how many of them I use. So you'll find in particular environments, you will obviously be limited in the number of threads that can run in parallel. I think it's the total number of logical processes available to you plus 2, but I might be wrong. But you can play about with it in your particular scenario. So I know from playing about with this on my dev machine here that I can run 6 in parallel. And what I found, again going back to the real world example, was where maybe I could run 6, it wasn't as beneficial as running 4. Sorry, I'll give you a better example of that. So where I was trying to run 8, but it would only run 6 at a time, it was more beneficial running 4, because what it would do is it would split up the workload between 8 threads, and then it would do the first 6 together, and then it would do the last 2 afterwards. Whereas if you just told it to do 4, you know that it can do 4, or even if you tell it to do 6, you know it can do 6. And it will do all, it will split up the workload between those 4 threads or those 6 threads, and it will do them all at the same time. It won't leave another 2 threads behind to run on their own. So obviously your dev environment will be different to your production environment. So it's just a case of playing about with it, but these parameters will obviously allow you to tailor this to your environment. And if you've got better machines and you want to have 16 threads or 32 threads, then by all means, you've just got to make sure that it performs. So what I will do is just take you through some of the details here. So this is exactly the same package I'm calling in all of the threads, like I've said. So if I look at this thread 1, what I'm doing is I'm calling my worker package. In terms of parameter bindings, because I can't specify, I can't pass in an actual physical value into here, I've got to use a variable. I'm using user thread number 1, and apologies here for this black background. It seems my machine here is a bit strange in that the drop downs just are black, which was interesting when I was trying to allocate variables here. I had to kind of guess where they were and just skip through the list, which was super. So we've got the thread number, then we're passing through the total number of records, which in our case here is 1,000, the total records per thread, which we calculated. We've got the API call, so that's the actual call to the API, and then we've got the number of rows per API call. So actually these last 4 are all consistent between every single call of the package. The only thing that differs is which thread number it is. So if I cancel out of that, the thing that controls how many threads we're running is just this constraint here. So our precedence constraint is just telling us for thread number 1, if the total number of threads for the package is greater than or equal to 1, then we're going to run this one, and it works all the way through. So here, thread number 4, do we have at least 4 threads? If so, let's do it. All the way through to thread number 8. I'm guessing you can guess what's coming up here. If I can actually click on it, there we go, 8 threads. So is there greater than or equal to 8 threads? So the principle of it is really, really simple. And you could actually have all of these 8 threads running in the same package. The reason that I don't is because where I'm calling away to an API here, or in fairness, if you're doing anything, if you've got 8 data flows, or you've got 8 different threads running in the same data flow, you've got 8 different script components. And if you've got 8 different script components and you need to tweak something because something's wrong, or they've upgraded the API, which they do, or something like that, and you need to tweak something, you need to tweak it 8 times. This way, we are, it's code reusability. Okay, so that is probably more than enough on the controller thread. So if I take you through to the worker thread, where all of the magic kind of happens, we have one data flow. In that data flow, we are downloading our data from our API, and we are loading our users table. So in terms of the load, very simple, just some straightforward mappings there, nothing crazy there. All of the logic is held in our download from the API. Now, we'll take you through the script here. However, I'm not going to go into a great deal of detail, but all of these resources are available on the website, so you can get both packages from the website, you can get the tables, and you can get the queries that I'm going to use in a minute as well. So it's all available there for you to work your way through. So I'm just going to open up this script. If it takes a little while, my machine is a bit slow sometimes. So here we are. I'll just drag it over to the correct screen. So what we have, so we've got our script component. Our script component is a sourced script component. And what we're doing, if I just take you through quickly, we are defining our, basically getting our parameter values, setting them as local variables. I've got an iteration number for logging. And then really the complex part of it to get right, even though it's pretty straightforward in terms of an algorithm, is to get the start record correct for each thread and the end record correct for each thread. So what we're doing is we're using this thread number. So if we imagine we are thread number 1, we have total records per thread, say, of 250. So for thread number 1, our first value would be 1 minus 1, which is obviously 0, times 250, which is 0, plus 1, which is 1. So that's our first number. If it was thread number 2, it would be 2 minus 1, which is 1, times 250, which is 250, plus 1 is 251. So thread number 1, if we looked at the end record, it would be our start record, which is 1, plus our rows per API call, which might be 10, minus 1, which is 10. Brilliant. So for each iteration, we're going to be doing 10 records, 10 records, 10 records, because that's what we've set as our rows per API call. That's our limit on our API. So it's getting those correct. And then we've got our final record number, which is our thread number times by the total number of records per thread. So that is where this thread is going to finish up. Because you don't want a scenario where each of your threads is actually, they're all running in parallel, brilliant, but they're all actually downloading the same data. So we want to be downloading a different portion of the data in each thread. So that's what we're doing here. And here, this part here, we're just saying if the final end record is greater than the total number of records, then set it to the total number of records, because it could be that if you're dealing with funny numbers, it's 1087, but you've come out with 1090 as your final end record. We'll just go and adjust that to 1087. So once we've calculated all that, it's just a case of iterating through until basically while our start record is less than our final end record. So we work our way through, we make our API call. So this is our base API call, and then we're passing through our minimum row and our maximum row, just appending that API call to get a specific data set. We're generating the API call, and then we are basically using this root class, and we're parsing our users list. Now I'm not going to go into JSON in any detail here. It is a JSON data set I'm working with. In the example that the previous working example that I used, it was a JSON data set. So if you are working with JSON, it's all about your class definitions. So you will define your JSON classes. There's a really good website available where you can actually pass in the call to the API, and it will return you a class definition, so you can use that as a guide rather than crafting it yourself like I've done before. But when you're talking to JSON or you're receiving JSON structures, then when you're defining how you're going to consume that, it's all about this class hierarchy. This has to mimic the JSON structure you're receiving, and then everything else will just flow. So here I'm parsing that structure. I'm saying I'm expecting this root structure, and then basically for each user, each record that comes through, I'm actually parsing and just returning to my output buffer each of those values. And then I'm just stepping through each time. At the end of each pass through this C#, I'm updating my start record, so I'm just incrementing by the total number of rows per API call, and I'm doing the same with the end record, so I'll keep going until that set has finished. So that's probably enough on that. Like I say, all of this is available on the resources page to have a play about with and work your way through. You might find it a little bit easier to understand if you work through it yourself rather than my description there. So what I will do now is jump back to the controller. I'm going to show you quickly before I start. So I'm just going to run a couple of queries here. So this is the table we're going to load. I'm just going to show you those tables are empty, like a magician. We'll show you the box is empty. Sorry, I'm just actually trying to work out where to go next. So back to the controller thread. So we have got 10 rows per API. We're doing 4 threads, and we've got 1,000 records in total. So each of those threads should do 250 records for us. So, without further ado, so it's going to jump about a little bit. It's just jumped over to one of the worker threads. So it's executing our 4 threads like we asked for. Each of the worker threads is doing its stuff. Shouldn't take too long. Right, we are done. So if I jump over to SQL Server here, firstly if I on our query, so we've got some data. Then if I go and have a look, there we go. So for each of our threads, I just output into our users table the thread number just so that we can do this kind of query, just so that we can see actually what's going on. We've had 250 records per thread, a total of 1,000 records. Okay, so now that we've looked at loading with 4 threads, I just want to show you the same scenario but with 8 threads. So I'm just going to truncate this users table. So we've got nothing in there. And then I'm going to jump back into Visual Studio, stop that running, and then we're just going to go and change this parameter from 4 to 8. Back to our control flow, hit start. Obviously we're going to jump around again, jump back to the controller. What you'll see is I've got these 6 threads running, so this is what I was saying, my system will only run 6 threads at a time. So it's going to run these 6 threads all together. Once all of those are complete, or in fact once a few of them are complete, it's going to kick into the other 2 threads. So those other 2 threads happened afterwards. So if you're dealing with big data sets, that potentially is going to slow you down, where you've got 6 running together and then another 2 coming in later and then doing their part of the work. So potentially actually just to run with 6 threads rather than 8 would be a better option. However, let's go and have a look at this data set. So if I run this now, okay, so what we see here is the outcome of a kind of a limitation with what I'm doing with Mockaroo. So instead of what you would expect, which is 125 records per thread, I'm actually getting 130, because regardless of how many records I ask Mockaroo for each time, each call, it always gives me 10. So even though in my last call I would have been asking for 5 threads, it still gives me 10. So slight limitation of Mockaroo there. Hopefully that just gives you another example there of running with 8 threads. So very quickly I will just cover off Mockaroo. So if I go over to Chrome, so here in Mockaroo, it's a nice tool. I've used it only very recently, I must admit, for generating test data sets. So here I'm generating a data set in JSON format. You can generate CSVs, you can, obviously there's lots of different output formats there. And here I'm basically creating a field here which is of type JSON array, and that's kind of giving me a wrapper around the rest of the fields here. And when we're doing that, I've kind of got user dot, and that is basically suggesting or saying that these fields are part of this array. So that is the schema, and then in the API, I've created an API here. This is where I'm specifying my minimum and maximum rows, but we've got a little example here. So if I go and click on this link, it shows you kind of the kind of thing that I'm retrieving. So this is the data set we're getting back. So you're more than welcome to use my Mockaroo API call. That's absolutely fine. There should be enough rows for you to download there. You'll also find the resources available on the website, so bidesign.uk, and the resources page there will have a download for SSIS multithreading. So if we just jump back to our package, I hope you found it useful. Let me know how you get on with it. Yeah, and good luck, and I'll see you next time. Thanks very much. Bye-bye.